the subtitles were coming simultaneously, right? So again, that was done using these machine AI ML techniques. So very interesting. I would be sharing some of these links with you, just for reference. So as you remember the first class, some of these features are part of a chatbot setup, right? Translation definitely might be a part, right? And then because not everybody will speak in English, definitely, or they will be comfortable in their mother tongue. So a translation module definitely is a good add-on to a chatbot. Anything else somebody wanted to share before we kick off the discussion? I see Kartireshan and Ashutosh and Srihari. The three people are not there, right?
So Ashutosh will not be able to join today. I'll
Okay.
contact him.
Yeah. So Kartireshan and Srihari are joining, right? Rest all, I think everyone is there, correct?
Yes.
You can ping me also, Hasita, on the chat.
Yes.
Yeah, no problem. Okay, so hi everyone. Let's start the class. As I mentioned earlier, around 10:30 we'll have a short quiz, right? Before that, let's discuss whatever the approaches you have taken or thought of for the deep learning problem we left the last class with, right? And today's agenda I will share after the quiz. Let's not talk about the agenda today. Let's not jump the gun. Okay, so anybody can tell me what approaches have they thought of or have started on the data set I had shared that day, right? Can anybody remind me what was the data set we shared? It was a chat data. I'm referring the chat window for that day. It was a okay topical chat, right? This was the data set.
Yes, sir.
Yeah, so I'm just opening the file. Are you a fan of Google? Okay. Oh yeah, yeah. It's like conversation, complete conversations. Yeah. So how do you use such a data for probably building a chatbot? Let me share the screen so that can you see my screen?
It's loading, sir.
Okay.
Yes.
Okay. So this was a data set shared, right?
Yes, sir.
Okay. So if you let me just put a filter here. Data filter. Oh, you have these conversation IDs. So if it is one here, means it's part of the same conversation, right? Yeah. So how many IDs we have here basically? Oh my God, 8,000 chats. That's a good data set. Okay, 1,88,000. Okay. Okay, so how would you approach? Maybe if you have to train a chatbot on this, how would you approach? Have you all done sequence to sequence model in deep learning or NLP? Okay, I mean, have you done LSTM?
Yes, sir. LSTM we
Yes,
did.
last class. I mean, last subject.
Okay, so in transformers, anything has been done like any of? So how do you kind of treat the sequential data, sequential text data? Okay, so one of the approaches you can take here is assume this is like first. I mean, this is the first line of a chat. This is the response, then this is the response, right? So you can pick it up like this. You can take, say, this line as the input, this line as the output. Okay. Again, this line is an input, this line is an output, and so on, right? So you will have this set of input output in your model. Okay. And then you can train a model. So Google Translate earlier used to be trained using an encoder decoder kind of architecture. Have you heard of it? Sequence to sequence. So it is like input, there's a sequence of text, output is a sequence of text, right? So input, if you give say an English sentence, and output is a French sentence, right? So that's sequence. So instead of giving English to French, you are giving English to English, because one is a response. So one is the input to the chat, and the other is response to the chat, right? So once you do this, see, this is like 1,88,000 lines, 188,000. So easily you are getting more than 350,000 lines to train on your model, right? So after that is done, your model will learn that, okay, when somebody asks something like, okay, how is the weather today? This is how I would respond. So did you get that idea of how how I'm asking you to approach this problem? That's one of the ways to approach. As I said, a lot of ways you can think of it. Let me show you the way I'm talking about. Uh, just one second.
Can we approach through the bidirectional LSTM as well?
Yes. Good point. So so the way bidirectional LSTM works is it will process your data like in one direction and then also in the other direction, right? That's the
Yeah.
whole idea. So
Yeah.
here, as long as you are considering in a way where your one chat input or one side of the chat is a response and the other side is your output, you should be good, right? So it's more, and the other thing you can do here is you can find out the intent of the chat as well, right? So but when you find the intent of the chat, you can do it like this. Okay, but before going there, let me show you this sequence to sequence. It is, as I said, it is not state of the art. It came, I think, let us open the Wikipedia page, maybe 19. Algorithm was machine translation in Google in 17. So 5 years back, it came. Okay, sequence to sequence model in machine learning. Okay, so technique, it turns one sequence into another sequence. Okay, it does so by use of a recurrent neural network, or more often LSTM or GRU. Okay, so as you guys just mentioned, as you all mentioned, LSTM is something you are familiar with, right? So a sequence to sequence is nothing but one LSTM in input, the another LSTM in output, right? There are some differences like attention, beam search, bucketing. The good thing is, for sequence to sequence, there is tons of more documentation or this thing codes available. In fact, there might be some well-known. Yeah, so this is how it looks like. The beautiful animation by Google. GitHub page. So you have this Japanese, I think this is Chinese. Okay. Okay, whatever. So this input language, right? And is your all these sections of the input, okay, or units are being fed, then a context vector is passed on from the last point, which is the end position, to the output, right? And that's the decoder. Okay, attention, you can read about it. Attention basically helps you understand, okay, for the word knowledge, which of these characters are important. Not everything is important because one of them is knowledge, right? So that's pretty much so sequence is popular because it is used for translation, right? Translation, but at the same time you can use it for training your chatbot as well, right? So let me share with you all this link. Okay, any questions on this one? Yeah, I mean, I hope you all get the idea on why a sequence to sequence is needed, right? Okay, very silent.
Yes, sir.
Okay, thank you. So, okay, so let me also share with you a Google tutorial on sequence to sequence translation. In fact, this whole, I mean, the whole, the link which I've shared includes example of translation and summarization as well. Please go through it. Yeah, it's an important one. And also I would like you to take that learning and apply it on this chat data set, the topical chat data set, what we have said, right? Maybe we'll use some time today to run that code, right? Another famous example which is there is the sequence to sequence PyTorch. Okay. So this is neural machine translation with attention, right? Okay. In fact, there is a Google collab as well. So the concept of attention, right? I will just cover in a high level. You see these on the left hand side, these are the input English sentences. On the right hand side, whatever language you are converting it to, right? Looks like it is Spanish, right? Casa and Estan, right? So do you see for the word home, which word is the like, so green is the color which indicates strong connection. So which word is green here in Spanish for the word home?
Casa.
Casa, right?
Yes.
Because casa is the Spanish. So if I do English to Spanish in Google Translate and I say my home, okay, mi hogar. What is that? Okay. What is casa then? Okay, let's write casa here. House. Oh, sorry. It's house. Okay, so home and house. Okay, no worries. Close enough. So home and house. So casa is the strongest. So when you have an attention mechanism built in your sequence model, it is able to make these connections. Which word is related to this word, right? And so on. In fact, a question mark to what are some of the other connections? Yeah, maybe no, not sure. Toda via. What does it mean? Let's see. Get. Okay. Okay, not sure if Estan. What does Estan mean? R. Okay. So wherever it is green, it is matching the word. So this is something what attention does, it teaches the model when translating which words are directly related or exactly responsible for this word being there, right? So R is coming from Estan. It understands that, right? That's the beauty of attention, right? And let me just see if this is having. Okay, so there is this language data set. So again, this is a sequence to sequence example collab.
Ravi, why
Yeah.
can't we directly use a lookup like a dictionary, right? Like which will be completely supervised. You know, there is grammatical context, there is structure, there is because language is not that random, right? Unless it's very colloquial or something.
So can you explain on what dictionary you mean by
So,
having a dictionary? Yeah.
for example, both the languages, the target language as well as your language, has a structure, grammatical structure, which can be
Hmm,
mapped. And you have the words, vocabulary, and the meanings associated as well, right?
correct.
So, would that not be possible to use that as a lookup and not
Okay.
train the model?
Okay. So no, I get your point. Very important question, right? So see, that would be very manual process. There is a dictionary, but somebody would have to. The dictionary was created ultimately in a manual fashion, right?
Yeah,
Now if you so if you if I mean you would have experienced, not sure if you have done that, but if I buy a French dictionary and I try to use it when I go to France to talk with people, it is not that easy, because I will have to, I mean, physical dictionary you have to turn the pages, that is separate, but it is like it is not very easy to do a conversation by looking into a reference like a dictionary, right? That's something. So just FYI, when I was a school kid, I had this fascination with languages, and I had bought a French dictionary, and I discovered that it is not easy to kind of find out what are the English equivalents, right? So I have done that, and I have experienced it's not that easy. But what you are saying can be done in a different way, right? And not sure if you meant that. If you take the vector space for
yeah,
French words, and if you take the vector space for English words,
yes.
and you use a text which has both of them, right? So for
Mm.
example, I think there are bilingual documents. In fact, Canada's parliament uses French and English both, because both are their official national languages or something, right? So all these things have both the languages, right? So document like that is very a good one for training such models, right? The translation models. And also I would say, when you are creating a joint vector space where these words come together, right? So where these words which like Spanish word for house casa and the English word house comes together, right? So that kind of thing can be done to translate. But again, this model is learning something different, right? It is learning that I mean, this translation model is learning what is that same thing which I just told, right? It is not different. Sorry, when you have this model completely trained, it will learn the representation of house, right? And it will learn the representation of casa, and both of them will be like, it will be similar, right? It is also coming up with a representation of the word house. How is casa related to house, right? So you are learning something similar, you are learning the vector representation. So yeah, so what you are saying is another approach, the bilingual vector space approach, right? That can be done as well. But this is also not a bad approach. All it is doing is it is teaching you, okay, this word basically is this one, right? Ultimately, when you train it on say 100,000 lines of English and French, it will start learning what is the meaning of whatever the French word oi is, yes, English yes, right? It'll start picking that up. It'll start picking up phrases as well.
No, because why I was wondering is because you were talking about multiple samples, multiple words, examples, scenarios to be fed into the model.
Yeah.
Would it not be more straightforward to feed that entire space itself, which is available, is what I was thinking.
Yes, that's something which has been done. In fact, it's if you remember the word to vec thing which I had showed you, right, which is like
Yeah.
very old, 7 to 8 years back. In that only people had done bilingual word to vec. So let me, I think my screen is still sharing. So word to vec. What is the best way to use word to vec for bilingual text similarity? Yeah, what you are saying exactly, correct? You are also looking
Yeah.
at bilingual, right? So yeah, this is something I have long back I had studied about this, right? So this photo reminds me. Survey of cross-lingual word embedding models by the very famous person, Sebastian Rieder. His GitHub links has a lot of information on NLP. So if you are making a career in NLP, his GitHub is very, very strongly recommended. So let me visit this page. So he's done a cross-lingual update. I mean, a survey of all these things, right? So do you see this is an Asian language with English, right? So cross-lingual word embedding between different. Okay. Updated version of this blog post in Journal of Artificial Intelligence Research as well. Okay, so I'm sharing this with the class. Have a look at this. So again, some of this is relevant if you are making a translation kind of chatbot. What do I say? Okay, this guy. Yeah. Okay. Okay, so let's then. I think everyone is in the class. Shall we start the quiz then?
Yeah, so we can start.
Okay, so then let's take maybe around 25 minutes for the quiz. 20-25 minutes. What do you suggest?
How many questions, sir?
20 questions, multiple choice.
Too less time.
Okay, so maybe we can take 30 minutes, right? That should be okay.
Sure.
It's multiple choice questions. Yeah. Okay, so Hasita, we can do a 30 minutes quiz.
Yes, sir.
Okay, then let's start. I will be in silent mode, but I'll be there. And yeah, of course, please, all of you come on camera. That is requested, as always.
So quiz will be uploaded in on LMS.
Yes, Praveen. It's in the
You can check
assignments.
with Hasita. Yeah, Hasita,
It's in,
go ahead. Yeah. Yeah.
it's in the assignments and assessment section, the same section that we have a final exam. If you go to that section, you can find the quiz link.
Yeah, best wishes for the quiz, everyone.
Thank you, sir.
Thank you, sir.
Sorry, I was on mute. Please turn on your cameras while you're giving the exam or the quiz.
Purnima, Pravina, Ritvik, can you please turn on your cameras?
Hashita, how do we uncheck? Because I mean, I'm able to check everything. Technically, there should not be option.
I didn't get your question, Sandeep.
I've checked some options. I need to uncheck them. How do I?
Clear answer you can do, I think.
Huh?
Clear answer.
Clear. Okay, okay. Thanks.
Thanks.
I think we need a chatbot for quiz as well, where we can answer basic questions using chat.
Vinay and Varaprasad, can you please turn on your cameras?
Asita, are you able to hear me?
Yes, Gautam, I can hear you.
Yes, I can hear you as well.
Yeah, sir, but my screen for that quiz got stuck. I'm not able to click on save and
Let me check also.
yeah, yeah. Please. So any update, Asita? If I close, I think it will go, right? It will get saved.
You can probably repeat the quiz then.
I have only one attempt, sir, maybe. Don't know.
Okay. I don't know. So maybe Hashita, we can help her.
Yeah, sir, we are checking.
Okay.
Asita, I shared a screenshot.
Purnima, I'll contact you separately. We'll solve it together.
So I hope everyone is done with the quiz, right?
Sir, can we give 15 more minutes for Purnima? She was facing.
Sure. No problems. Sure. I mean, have people already completed? I see Shiv Priya's message saying she's completed.
Yes, sir. A few students have now.
Okay.
Yeah, I've completed.
Okay, so Shipriya, your earlier point, just wanted to make one additional comment, right, about the bilingual embedding. That can be used for finding uh, words in different languages which have the same meaning, but for conversation it will be difficult because not every time you will have word-to-word translation which will work in a conversation, right? Because a phrase might have a different meaning than what the words mean. So, Shipriya, this was to your earlier point about the bilingual word embedding.
Got it. Got it. No, I was just wondering because of, in the sentences especially,
Mhm.
can that be represented, as a graph and an equivalent graph on the other side can be like
Okay, we
picked
didn't
up?
favor.
Yes, just like embedding, you can do a graph. There are graph related work in translation, but I've not heard people using graph for translation as much.
Okay. But any other field where it is used within NLP, the reason why I'm asking is that,
So this grammar aspect of it, the sentence, people
yes,
do it using graph, and the entity recognition thing is also a graph, right? The entity and the
yes,
relationship between them. So
correct, that's
definitely,
what.
that's a
I don't
graph
think.
as well.
Okay.
Yeah, it's allowed me to attempt.
No, because
Minute
when during the
15.
assignment of that Wall Street problem, we had, for example, in a sentence, it is taking up three words and it's just showing that there is a context, right? Like they are all
Mhm.
dependent on each other.
Yeah. That's a parse tree. That's a parse tree in computer science. It's like you have all those elements of the English grammar. It shows the relationship between what is that? I mean, this is a verb related to this object or something like that.
Got it.
That's again a graphical structure. Yes. Ashita, I'm sharing the slides for today with you. You can pass it on to the students.
Yes.
Hasita, this I submitted, but for last 5 minutes it's going on like this. The timer is going on.
Mm.
Can you send me a picture of the issue?
Sure. Yeah, just give me a moment. I'll just share that. So it is working like this. This timer is ticking. There are 45 seconds now, and this is. Can you see that, Harshit?
Yes, I can see. So you finished the quiz, right?
I finished the quiz. I submitted it.
Okay, can you wait until the timer goes off?
Sure.
I think it'll automatically.
Sure. Thanks. I even tried canceling it and submitting it, but the same thing happened. Hasita, I'm seeing this now.
Okay, Soumya, then we'll solve this offline. I'll give you a call.
Thanks.
As some students are still to give the exam, we'll not discuss the answer, probably, right? Otherwise, I'll have to
Yeah,
set up a
please.
new question paper for them. So, what's the average for folks who have submitted till now? Anonymous average.
I think 65 to 70%.
Yeah, I would recommend people to stay on camera even if the tech quiz is off. Hi, Hashita, I have shared the slides with you. You can check.
Yes. Soumya, your quiz got submitted. We can see your results. I think it got automatically submitted.
Okay, yeah. So what does the score look like? Average or whatever?
So it's around 65 to 70. The average.
Okay, on average. How many
Yeah.
folks? How many people have submitted?
11 students.
11 out of
14.
15, 13,
14.
14. 14.
Two students are
Okay,
absent and 4 marks basic.
okay, okay. So how was the quiz? I mean, in terms of, I mean, was it like based on what we covered?
It was easy, but I got confused with all of the above, none of the above.
Okay, yeah, that was the idea. But yeah, the topics were like taken in a chronological order from the topics we covered in class, right? Of
Yeah.
course, in a MCQ, I cannot give a code more code. It wouldn't look nice actually. But yeah, we will have say the final exam as well. And I was just thinking if we should do a project as a part of assessment because chatbot is such a practical subject, right? I think I mean I think exams and quiz don't do justice to chatbots or conversational agents, right? So, what is the view of the class on the I mean assessment being on a project as well?
Sure, sir.
Yes, sir.
We would like to take that.
Okay, so
However, we
But
have a
if we
mini
are stuck
project
in
which
between,
we can submit it as well. If we are divided into groups, like just wanted to
huh.
understand if it is a group project or an individual project, so it will be easier.
Yeah, yeah. So whatever works out best, right? So again, if everybody does their own project, it will be difficult for evaluation. So maybe a group project is also fine. I will check with Dr. Shinu and I mean the Reva team as well,
Okay.
and let's just discuss. But yeah, definitely a project makes sense in conversational AI.
Yeah.
Much more than a. By the way, this quiz is graded. It's not that it's not graded. It will be part of your grading. But yeah, the quiz was just to like refresh your memory in case you have forgotten or maybe missed out, right? So shall we? Okay, no, it's still going on for some people. So let us know, Hasita, when we can start the class.
Also, we can start it off. Only Purnima is left. She's going to take it, right?
She's going to take it later. Okay, fine.
She's gonna
Okay.
take it right now, so we can
Oh, right now.
continue
Okay.
with the class.
Okay. So, but she'll. Okay. No worries. So yeah. So okay. Very good that we have most people on the camera. Let's continue like this so that I kind of can register what if I'm being understood or not, and it feels like a class. So let me share my screen. A lot of things to cover today. So let me know when you can see the screen. I'm sharing it now.
Sir, one request.
Yeah, sure.
We have covered, say, LSTM, and we have touched little bit of transformer as well in earlier modules. So earlier, so can we look into the any of those uh, models, maybe transformers, very closely to understand how the inputs are made, how do we change the dimensions for the inputs. Uh, Most of the time,
Mm.
whenever we are feeding in the data, that time the error happens.
Okay. See, I mean, I would not be able to cover transformers as like a subject, but I can definitely point you to very good resources which can help you understand. In fact, one of them, let me point to you right now, or point to all of you right now. It's called J Elmer. What is his name? Just 1 second, please. Let me Google for his name. So J Elmer Bert. Yeah, sorry. Okay, J Elmer. Yeah, J. So, so gentleman called J Elmer. He writes visualizing machine learning one concept at a time, and he explains everything using visuals. It's an excellent way to learn, right? So to your point, transformers have been explained very nicely here. So just explore this GitHub link, okay, everyone. The class, it's amazing. Okay, so Soumya and others, please explore this. It's very good. It covers a lot of things, including word to vec, doc to vec, BERT, transformers, everything, right?
Thank you, sir. And the challenge or the where I'm baffled is after covering so many concepts,
Mm-hmm.
so there are certain confusions arising, and there are some thing which I tend to, uh, I mean, my memory loses over time. So I needed some concise reference. I think this one you shared is going to help me. Thanks for that.
Yeah, so yeah, apart from that, see, there are books also where you can read. So one of the books, again, it is not specifically to this course, but it's my favorite because I take another course called Deep Learning for MBA folks, and I refer that, or I have recommended that book to them. It's called Deep Learning Using Python, and the author is the creator of Keras, Francois Chole. Right. So the edition 2 has come just this year. You can probably buy the ebook Kindle version as well, right? So I'm just writing that name. So that's a very good book for deep learning, one of the best books in the world. Uh, it's called Deep Learning with Python by Francois Chole. Francois Chole is a Google employee who is the creator of Keras module in Python. So he's really good, and his book is really interesting. So these two resources, please start with it, right? And so let's start today's session. I am going on a slideshow mode. Do you see the slideshow mode?
Yes, sir.
So quick recap. The we last week we covered, among other things, a discussion on the graph portion, some of the ways to approach the problem. Again, as I said, it's a very open kind of problem. There is not a single way of solving it. It's also the way you represent the data set, right? And also, while representing the data set in graph format, there are some tools available as well. Like one of them, I think is, I think I shared is Prodigy, right? Just explore it on your own. Apart from that, we looked at Rasa NLU, where we went through each and every, or rather a basic example, but we understood what all things are lying under the hood in Rasa, and that's including the NLU file, the how the entities are defined, how the stories are defined, right? That was all about Rasa NLU. There are okay. So further to that, there are very good YouTube videos. In fact, articles on media. Articles on Data Science Central and other things, other similar websites where they take you through detailed examples, sales chatbot and whatnot, right? So have a look at that Rasa and LU examples. Dialog flow, we saw how easy it is to create in the dialog flow, how to create a basic chatbot in a dialog flow, right? We saw the example of appointment creator or appointment scheduler, right? Now that appointment scheduler, and also there are some other examples, right? So again, to refer in details for Dialogflow, you can refer the Dialogflow YouTube channel by Google. Very interesting, right? So that's something I would like you to further take action on these two, right? So let's start with today's topic. Today we are going to do a bunch of codes, which is very important, right? But before that, some theory, right? So let's talk about some properties of conversational agent. uh, okay, so this is too much text, but I just want to like have this as a conversation between us, right? Between humans. None of us are chatbots, right? So let's do a dialogue here, right? So what are some of the properties of a conversation? So dialogue has a structure. When we are talking, or sorry, when a conversational agent is interacting with the humans, right? It is a combination of turns between agents and humans, right? It is in case of a conversational agent, it does not happen that both you and the agent speak at the same time. It is not possible. It will wait, right? It will wait for your response and then give a response. That's what happens. So it has a structure. Dialogue has a structure, combination of turns. There is a very good or very interesting point about endpoint detection for dialogue management. And DMS system, dialogue management system, is something to do with, one of these things is endpoint detection, but also things like adjacency, sub elements of a major element. How is your daughter doing? Yesterday I saw her sneezing. Again, it's talking about the same subject, but two different things, right? I'm planning a trip to Goa from where? Delhi. So in the chatbot case, when a dialogue management system you are designing, you need to keep track, or you need to keep ensure that things like these are handled, right? If somebody asks, I'm planning a trip to Goa, you cannot just show a flight from to Goa from maybe top 4 cities in India. No, you will have to narrow it down to say from where, right? But maybe, okay, and one exception, if you are tracking the user from a long time and you know that the user typically takes a Bangalore to Goa flight, right? Then probably you can make a recommendation, default recommendation, just an exception. So is there any morning flight? Morning. So if there was no adjacency, if we wrote if we just wrote a very detailed way, it would be like morning flight on which day, which city you are from, and which city you are traveling to. And with adjacency, you can just say, okay, here are 3 flights. You can just pick one of those, right? By the way, adjacency is just a concept where you have elements within the English, the sentence, and you are just finding what's the relationship between them, right? So these are some of the properties of a conversation. So what do you think? So here is a question for the class, right? What do you think are some of the properties of conversation which a chatbot needs to understand for a perfect experience of a user?
Intent,
Definitely, that's a good point. Intent is definitely, otherwise it wouldn't know how to respond. Anything else?
keywords,
Keywords. Okay, so you are making a keyword based chatbot. So if the word has the word cancel in it, you are probably then going to show the user about options of canceling the ticket, right?
yeah.
Okay. Anything else? What are some of the conversation? So it looks, so it's like you're preparing for your project here, right? This discussion will help you prepare for your project.
Maybe a context also needed, right, in order to identify the
Context is
intent.
needed. Yeah.
Correct. So those are the type of chatbots typically, or agents which we deal with, right? Context is very important. Some people have a confusion. I'm not saying that in this class I don't see that confusion, but there is a difference between keyword and context, right? Not necessarily when you understand a keyword that the context is the same. So maybe the word cancel is there, but maybe the user is saying something else, right? Maybe it's not about canceling the ticket. It is something. So user is saying something like, I canceled the earlier plan, get me a modified ticket, right? So
Yes.
the word modified is also there. So just by looking at cancel word, if you take an action, it will be naive. It will not be a good experience for the user, most likely, right? So that's the danger for keyword based chatbots. They will work most of the time, but when they will fail because they are not taking the whole context of the word, right? Cancel word in itself is not necessarily indicative that something is going to be cancelled. Okay.
Sir,
So yeah,
one
go ahead.
question. How to differentiate between domain and context? So domain also
Uh,
provides some broader level context.
Domain. So okay, domain is something which you are probably clear about when you are interacting or when you are designing a chatbot for a company's domain you are clear about, right? Unless you have a chatbot which is pretty open domain, right? Like Eliza. So one of the quiz questions was on Eliza, right? So Eliza was a chatbot which can talk about a lot of things, including weather, but it was all hard coded, right? So domain is something which you know about, and your chatbot is created in such a way that the domain is handled, right? So it can be an airline booking domain, airline or ticket booking domain, or maybe a school domain, that kind of thing, right? School, I mean, whatever, college, university students, library domain.
Yes, sir.
So
So,
intent, yeah, go ahead.
sorry. So the context can also be driven, or it should must always be driven from the domain.
Yes, makes sense there, right? Because if there it's an airline domain, the context can be cancellation, modification, flight status check, and those kind of things, right? They can be intent. The context can be similar to an intent here, right? Context can be gathered from the intent itself.
Okay, sir.
Is that like confusing, or am I clear?
No, I'm trying to absorb. You are clear, but
Hmm,
I'm still
okay.
trying to absorb it.
Okay. So okay, just to simplify things, intent is intent. What do you need when you type that thing, right? What are you looking for? That is intent. Context is a larger, I would say, bucket, right? It's like what's the context in which that intent is expressed, right? So intent can be, so as I said, the intent is modifying the ticket, right? And the context is I have an existing ticket, I want to cancel it and I want to modify the ticket. So that's the whole context. Does that help you understand?
Yes, thanks.
Okay. So that was the so that's the start of a dialogue system, right? Dialogue management system. Now, if you remember from the first class, the DMS or dialogue management system has these buckets. Sorry, has these boxes where this DMS dialogue management system and the dialogue state tracker are some of the boxes, right? So some of these things come from context itself, right? So if you are able to identify the context, the intent, and the entities, then your chatbot will do a reasonable job. Of course, it has to have a response for those combinations, right? That those response need to be produced. So let's look at some of the other things here. So temporal understanding should be there, right? So if I say, so again, what is temporal understanding? So yeah, not sure I got stuck here. Yeah, so what is temporal understanding? Temporal understanding is basically something to reference with time, right? So if you remember the appointment scheduler, I can say to appointment scheduler saying I need an appointment for vehicle registration for tomorrow 4 p.m. right? So tomorrow 4 p.m. or or I can say maybe 3 days after, or 3 days later, rather 3 days later at 3 p.m. Right. So that temporal understanding in the chatbot should be there. That 3 days later means today the time is 30th of July, and they are talking about 3rd of August or 2nd of August, right? So that is temporal understanding. And also the responses in terms of inference, right? Conclusion. So a good experience can happen if the chatbot is able to infer and also respond, right? Or conclude. So one way is okay, thank you. Okay, so it's like it's done, or whatever input or whatever you came to the chatbot for is completed. So the chatbot can also respond, understand, and say, okay, thank you. Would you like to book the first one from the three? Can be one question, right? After showing the object, you can, or after showing the three flight options, maybe the chatbot can be proactively and say this: would you like to book the first one? And would you like to book the second one? No, thanks. Where is Paris, France, right? So this is not a great example, what I have shown you here, right? Would you like to book the first one? No, thanks. Would you like to book the second one? Rather than that, maybe it's some internal maybe logic when you are building for an airline domain, where it knows that okay, if I score based on something, the all the options which I have, maybe the first or the second one is the best for you, right? So something like that, maybe something like that, we're saying okay, looks like because this flight is we recommend this flight because it is after 8 a.m, right? Because see, 5:30 a.m flight, not all of us are comfortable taking it, right? So unless there is like no other choice, right? So maybe 8 after 8 a.m. this flight is there, and after 6 p.m. in the evening this flight is there. So maybe some logic like that, right? Rather than asking the user, would you like the first flight? No. Second flight? No. Third flight? No. Right? That is not a good experience, right? So hope it is making sense, right? What I'm talking about in terms of the intelligence, in terms of delivery of the chatbot, right? The what the response that chatbot is delivering or the agent is delivering. Any questions? Okay. So, okay, next thing is action identification, right? So you can book a table on a flight. You can book, sorry, you can book a table in a restaurant. You can book a flight. You make a transaction, right? Now that's all well and good, right? But again, some intelligence would be good, right? So if I have I mean, it's not just like a simple, very basic chatbot which just takes the input of the date and says I will do it, right? Rather than that, maybe it has like access to a calendar where all the public holidays in India are mentioned, right? And they can say, can you book, when I say can you book first flight on next Monday, it can say next Monday is a holiday, do you still want to go ahead, right? So again, those kind of things make the chatbot experience quite handy, quite good, in fact. So that's one of the examples. Now, how do you also, right? See, now we are discussing on what can be a good, I mean, what do you say, good response for a chatbot. But how do you make the chatbot utter these responses, right? It has to have some internal mechanism where it can generate a score, right? Confidence metrics. So one of the things where, so one of the examples we'll be doing today is using deep learning, we will identify the intent, right? Now this intent, if the chatbot comes out with the output saying with 5% intent, or sorry, with 90% intent, I think this is a cancellation flight thing intent. With 10%, I can see this is a modified flight intent, right? So then it will go ahead and offer you cancellation things with information, right? So that's a score. Now that score is coming from the model which is trained on past data, and it is generating a confidence score, right? So that confidence score is just one example metric I have given you. There are multiple ways to generate that confidence score. There are customized way you can generate, right? For example, a chatbot where you are choosing a product based on the user input, right? You can, you have 15 products in your backend, and you can assign a score to each based on what the user has inputted and show the or input and show the top scoring one, right? So again, that's a different kind of score. So again, this confidence score can be of multiple type. Okay, so I think it's 11:30. Let's take a 15 minutes break and we'll come back and continue the discussion. Okay.
Sure, sir.
Thank you.
Sure, sir.
Hi everyone.
Hello, sir.
Hello, sir.
Yeah, hi. So all are requested to come on camera. We'll just start in a minute. Shall we start now?
Yes, sir.
Okay, let's start. So let me share screen. Can you see the slide?
Not yet.
Now?
Yes,
Yeah.
sir.
Okay. So we discussed till confidence score, confidence metric. Let's move ahead. Uh, so what is the definition of a context? Right. So a combination of keywords that define a theme, action, event, an entity, named entity recognition, NER. Another set of keywords, compute the probabilities and score the context, sort it based on score. So again, it's just saying what I was mentioning earlier. When you are coming to when you are rather identifying a context, right, you can use, you can come up with your own scoring mechanism, or if you are doing it using a deep learning model or any model, you can use the confidence score of the model, right? So again, e- defining a context is fine, but or rather predicting a context is fine. But if you are extracting the context from the text, there might be multiple ways of doing it, right? So the very first class I gave an example of a product-based chatbot or a product chatbot where somebody asks for a system and what all specs are there in the system are extracted from the text, right? So it is being extracted from the text information, and based on that, the product which you have is scored against that extracted information, and then you show the top matching product. Right. Now there can be a rule-based system where you define the action: opening, closing, shutdown. So again, these are some banking examples. You can define events: prepayment, foreclosure, withdrawal, deposit, product names. NER can be product names. I have opened a bank account. I did not do any deposit or withdrawal. Went to US for 3 years. Now my account is closed. Right. So these are some examples of a complex query, right? So when you have to handle it, you need to come up with intents and then rank the intents on what you can probably start with, right? Something like that. Again, these are some of the complex examples. Okay. Any questions till now? Okay. So there can be a context scoring as well. I mean, there is a context scoring as we discussed, but let's understand some very simple examples how we can do that, right? So you can have an account opening indicated by a list of keywords and a product list of keywords, and an action has a list of keywords. Action can be cancel or anything, right? Or any similar things. Now user says, I'll gives a list of words as an input, right? User says, I want to open my account, right? I want to open a new account in SBI. Now, out of 5 words here, 4 out of 5 are from A, list of words in A. 5 words, 0 are from B, product list, and maybe one of them is from action list, right? Now, if you now in this very simple context scoring example, your input from the user or the user's input is most likely an A because 80% of the words are matching with A, right? Now, I'm not saying that you always do word matching, okay? But you should, I mean, this is an example of how the scoring happens. Out of, if you have 3 possible contexts, you can have one of the contexts getting highest score. Now there might be a special case where the user is not asking any relevant question. Then all your context might get a score of maybe less than 5%, right? So in that case, you reply to the user saying, I do not understand. Please rephrase your question. Something like that, right? So scoring is very important here, right? Now, again, some examples. When you give an order to maybe a chatbot on Pizza Hut, right, or Domino's, I want to order 3 pizzas and 6 bottles of water. When do you want to be delivered? So the bot has already parsed what are the quantity of pizzas and 6 bottles of water. Right now, one thing which is missing here is which pizza. The bot wants to get that detail, but before that, it wants to ask. It is asking when do you want to be delivered. Now, up to you as a designer of the conversational agent. You want to first get all the orders, get the numbers and the date and time. Then you further deep dive. You say, okay, which pizza do you want? Here are the top 3 pizzas. If it is an existing customer, you can show them, right? For example, you must have seen in the Swiggy app, the in the Swiggy app, if you have already ordered from a restaurant, the moment you go to that page, it will show you the past orders, right? It will say, okay, you already ordered maybe laddu from here, or already ordered maybe dosa from here, right? So it is making an assumption that because you have liked this and ordered, or probably have ordered multiple times, you again want to order this. It is saving your time, right? So a chatbot can have the same feature. It can, if you have visited chatbot, it is on a Domino's pizza, it knows your login ID, my email ID, Ravi. It knows, it can suggest me, okay, here are your favorite orders from the past, right? It can automatically show. So those kind of things, all these things have to be kept in mind when you are creating a solution, a conversational agent. Any questions on that? Any, or not just questions, any feedback, any points which you think are relevant? Okay, so let's now
So
do,
this
okay.
recommendation already they process in backend and keep it ready. Is it whenever the user logs in, they will populate the recommendation, or based on
Uh,
his recent searches, they will populate?
Yeah, that's a good question. So it again depends on the feasibility and requirement of the business, right? So if Pizza Hut management says that you're a designer, you are a data scientist, and you go to Pizza Hut, then or Pizza Hut comes to you saying design a chatbot for me, then you and Pizza Hut will sit and decide. If I show the customer when they log in, when he or she logs in, I would say, I would show them their last 2 3 orders, or maybe top orders they have done in the last 1 year, right? So they would say, okay, yeah, it's fine. I think that's a good one, right? Or you can make it more intelligent. You can say these are some of the orders you have ordered. Now these are some of the recommendations based on this order, right? So you can do some kind of Netflix kind of recommendation. You know, Netflix is the most popular example of recommendation. Based on the movies you see, they will have a special line for you saying recommended for you, right? So if you see a lot of spy movies, it will kind of, maybe not only spy movies, it will show you what other people watch when they watch a lot of spy movies, right? So the other kind of genres as well. So that kind of thing also, it's up to you when you design it, right? So recent searches, if you want to take into consideration, you can do that. You can, based on that real time information, you can run your recommendation engine. The recommendation engine will give an input to your agent and it will generate the options. Okay.
Got it, sir. Thank you.
Okay. So all this I'm discussing because this is what a production conversational agent should have. If you are able to make this, it will be a very good achievement. Actually, it's a good achievement. It's something which probably is ready for facing a what do you say, industrial use case, right? Industrial use case chatbot. So yeah, one thing I would suggest to all of you is have a have a look. Everybody has a chatbot now. Have a look on chatbots whenever you are visiting a website. Maybe interact with the chatbot. Okay, do a test transaction or something, or not transaction, maybe a test conversation, and see how you can improve that chatbot, right? If there is something, or maybe they already have a very good chatbot, you can probably pick up something from there, what they're doing, right? So have just do a survey of chatbots you see all around. Yeah. Okay, so let's do a hands-on session on contextual chatbot. Okay, I need to share screen one more time just to. Mm. So this contextual chatbot, why are we calling it a contextual chatbot? It will, okay, I'll be sharing with the class one file called a JSON file called intent.json. We will see that file, how it looks like shortly. And we have in that intent.json some tags, questions, and responses. And that's where we will use to make a contextual chatbot. Let's understand that by looking at the code. So I will stop sharing and I will open the code. Just give me 1 second. I'm sharing my screen. So see, this is a JSON intent.json file, intents.json. Okay, you can intent.json is also okay. So this is in a JSON format. You can say, okay, folks, you have done Python, right? What is this data structure? Or what is this a list dictionary? What is it? Question to everyone.
It is semi-structured data set.
Hmm. Okay, but it has some dictionaries in it. Do you agree?
Yeah, dictionary with list
Yes.
as well.
Yes.
This okay. So yeah, it's a data structure where it is basically it's called intents, right? And what it is doing is this might start reminding you of in a way Rasa and Google Flow, Dialogflow as well, right? Why? Because it is giving an intent which has a tag name of greeting and which has some patterns. What are these patterns? Patterns are nothing but what are something which the user can input and get classified as this intent, which will get classified as a greeting. Hi, how are you? Is anyone there? Hello, good day, right? So, and responses are what responses are there for this particular kind of input. Hello, thanks for visiting. Good to see you again. Hi there. How can I help? Context set again, here it is not saying anything. You can probably give a context set, right? Something like, so for example, in rental day is the context set. Okay, it's just giving some amount of context on so for example, the word is today. For rentals today, please call this same day rentals, please call this. So it is the context here is rental day. You have just given it a tag, right? So similarly, there is a goodbye tag, there is a thanks tag, there's an hours tag. So this looks like you have a moped shop which gives you for rent, right? That is what it looks like, correct? Okay. So this intent.json. Doesn't it look similar to maybe something we were doing in Rasa and maybe also in Google Dialogflow? We were creating intents and entities, right? Custom entities. So also our custom intents, right? So it's the same thing. Now the good thing is now you will without using Google Dialogflow or Rasa, you will see we will use a machine deep learning model using TensorFlow, right? I will walk you through the code. I will not run the code. I will request all of you to run the code. I will share the code shortly. Before doing that, I want to run through the code or walk you through the code rather. And intent.json is the key input here, right? So let me open the code. It's in my Google Colab. NMT, yeah, contextual chatbot, NLP, and TensorFlow. So again, it's been taken from a GitHub repository. That intent.json file is also from a GitHub. It's actually same, right? So can you guys do one thing while I'm running through the code? You can at least download the intent.json file locally, right? I'm giving you the chat. I'm giving you the link. Intent.json file and the code. Okay, I will download the code and share it on the. So so it is it the correct code? Let me see. I want to check if I am reading this same. Is it the correct intent? Intent.json file. I have multiple. Okay, it's the same. Maybe it's it's the intent.json file is slightly different, but that does not matter. We can probably just make a few differences or a few changes. Okay, so this code is basically running, taking that JSON file, and as I showed in this JSON file, it has the intent, it has the input pattern, it has the response pattern. In some cases, it has the context as well, right? So the beauty of this approach is you train on these examples, and even if you change them slightly because the model is trained on it, it will capture. Okay, you are trying to, or it will capture the intent very nicely, and it will respond to you, right? That's the beauty of it, right? Now let's quickly run through this code before I hand it over to you to run it, right? So I'll just walk you through the code. So you import these libraries, including TensorFlow, right? Import tflearn, import random. Then they are doing contextualization by using a stemming. They are using a stemming also, right? I hope you have covered stemming in your NLP class, right?
Yes, sir.
Okay. So yeah, JSON file we are reading. So it's importing JSON, pickle and warnings and all that, right? Installing tflearn, processing the intents. Now it is reading intents.json file and then loading it, and it will then have that JSON file which we just saw loaded, right? Now from that it is separating out to convert them to words, classes, documents, and ignore words, right? Again, some Python code here. We will run it on our own. For pattern in intent, for each pattern, it is tokenizing each word in the sentence, adding those words to the words list of words, and then adding these intent tags to the document corpus, right? And then adding the tags themselves, the intent tags to the class document, right? So this class will ultimately contain this greeting, goodbye, thanks, hours, mopeds, and so on, right? So that's what it is, just separating out the JSON file into different lists. That's what it's doing, looping through the intent to convert them to words, classes, documents, and ignore words. Now, and all this rest is cleaning the data, stemming, lowering, and removing duplicates. So as you can see, the output of this guy is 9 classes: goodbye, greeting, hours, mopeds, open today, payments, rentals, thanks today. As I said, these are all tags or intents and unique stemmed words from the, where have these come from? From this. Okay. Patterns. By again, because they are stemmed, so sometimes they look very strange, but that's a good practice to stem the words, just avoid duplication as well. Now it's just creating data for training, creating training set, bag of words for our model. I would not prefer a bag of words. I would prefer actually a deep learning model to do it. Okay, let me do this. This guy would have a context aware chatbot, would have the code itself. We'll rather use that code then. Okay, I can. How do I reach the? Okay, I'll just say GitHub. Yeah, maybe yeah, this is the code. Okay, this is fine. So I can actually give the chatbot link as well on the chatbot on the chat here. So you have now the JSON file with the intents and the chatbot code. I would request you to run it, but before doing that, before starting, let's just see the output here, right? Shuffling randomly and converting into NumPy array for faster processing, creating train and test list. Okay, before that, they were creating the data for our model, creating a list empty for output, creating training set, bag of words for our model. Okay, so it is creating a bag of words approach, which is a basic approach in NLP, but very powerful, where you take all these words and then do a kind of represent using a bag of words model. Anybody who has, I'm sure you would have covered bag of words, right? When you started NLP.
Yes, sir.
Yes, sir.
Yeah, it was.
Okay, okay. So then you know that it is like a one hot encoding kind of thing, right? Output is a not one hot encoding, but output is a 0 for each tag and 1 for current tag. Okay. Basically means whatever tag is present, it shows up as 1, the others shows up as 0, right? Training dot append bag output row. So that creates your training data. Now training data was basically the text which you have, okay, and the tag. That's what you're training on, right? So now you are separating the training into training and test list. Then you are running a TF learn model, a TensorFlow model on this, right? Again, this code was taken from GitHub and maybe slightly old. I'm happy if you want to change it and use maybe latest Keras TensorFlow as well. That's not an issue with me at all. So TF learn not fully, it's running a TensorFlow model and it's uh, length of train y0. So basically whatever is the tags there, okay, activation is softmax. Okay, learn regression.net, tflearn.dnn, net tensorboard directory, training step once. Okay, so we can modify the training, but let's see what's the final output. You have saved it, loading pickle file. loading the training data, or rather training this pickle file training data I've opened. Now you have shown the words print loading the model. Okay, you have loaded the saved model here. Clean up sentence words NLTK word tokenized sentence. Error threshold, classify sentence. Okay, so this is basically now it is inferring your data set or inferring on your test data set, right? So it is now classifying the sentence. Okay. Now it will in the once it is able to classify that what you entered is actually belonging to this intent.json file which I just shared, and it is dependent and belonging to the happy tag, then it will give you a suitable response. I think it's here. While results, if find intents tag finding, if I tag is equal to result 0, return. So it is randomly picking up one of the responses from the JSON file, right? So that's what it is happening. So here are some of the examples. You the chatbot says hi, or you say hi to the chatbot. The agent says, "Hi there, how can I help? Need coffee? Hello, thanks for visiting. Quit. Hi there, how can I help? Bye. See you later. Thanks for visiting." Right. So can we just maybe run this and try to replicate this in our respective setups? Okay, and when you run this, you will be clear on what each action is being or what is each step happening here. But at a high level, is it clear what we are trying to do? We are training a chatbot, a deep learning based agent on a JSON file which has all the intents along with their responses. Okay. So can you just all of you please start doing this, use this code, replicate in a Python notebook or a collab, and also use the JSON file which I have been shared, which I have shared above that. Yeah.
Sure.
Let me know any issues. Yeah, please continue the camera as requested earlier. And everyone is requested to work on the problem as well. Anybody who has resource challenges in terms of running the code, please use collab. In case your local machine is not able to run the deep learning code. Any issues, setup issues before starting for anyone? No, right? Okay, cool.
Not yet, sir.
I see 3 people on the camera. Others are requested as well, just like you did in the quiz. So I'm assuming there is no resource issue there.
We'll switch on after a few minutes, sir.
Okay, sure. As long as you switch it on, that's fine with me. Yeah, so there are examples on the web on intents.json, and but the whole idea here is you can create your own intents.json, just like you were doing in Rasa, where you were creating intent and examples. This is your own way of doing that in a Python as a Python code.
Sir, I'm able to run this.
Mhm. Okay, the entire thing.
Yeah, entire thing.
Okay, can you share the output, please?
Yes, sir. There were 2 changes which I had to do because of TensorFlow. It is using the older version of TensorFlow.
Uh-huh.
So
Yeah. So yeah, I'm fine if you can. If you want to do tf.keras and all, that's fine with me. So the only that portion of that processing the data for input and the running the model will change. Rest all concept remains the same.
Yes, sir. So where uh, I should go?
No need to change now. I'm just saying as an advice. You can just show us the output of each box of yours, so
Okay,
that we
sir.
are all clear what is happening.
Yes. So the first step was that I had to install the tflur. This library
Mm-hmm.
was not there, and these are the imports. Then again, this particular package.
Mm-hmm.
So this is reading the JSON, and after that,
Okay, sorry, Swami. One favor. Can you just print out that JSON file after reading it, just so that we see it's the same JSON file?
okay.
I think you can also show it as a data frame, right? Just for ease of viewing. The JSON one allows you to do a JSON. Yeah, what does intent will have? Intent will be a raw JSON file, right? If you print
Yes, sir.
intents rather, just see.
This is the
Yeah,
raw.
it's the same. It's the same thing. Okay. No worries. Then let's go ahead. I mean, one of the things we can do later on is maybe just convert it into a data frame, pandas data frame. That's fine. Just for ease of viewing. Okay. Now we continue. We just show us the output of this one. Yeah. So it is 27 documents, 9 classes, 48 unique stemmed words.
Sir, just one thing. So when we say 27 documents, classes are fine. You told in the beginning these are the classes,
Uh-huh.
and
So I see what the documents mean is basically it is taking hi, hello, how are you? Each of them as a different document. Is that what it is doing? Can you just see the document code and let's understand for ourselves what it is doing?
Yes, sir. So documents is coming from here.
Yeah. So for intent, so for each intent in intent intents, for pattern in intent patterns, it is tokenizing the pattern documents dot append w intent tag, right? Why don't you print the document? The document is a list, no? You will quickly find out. Let's
Yes.
print the document
So
in a
we are,
new. No, you are printing length of documents, not. Yeah. So it is document is nothing but each keyword along with its tag. Sorry, each document along with its tag.
I'm trying to map this hi to greeting. So okay, this is the
You understand, right? Hi, greeting. How are you greeting? Is anyone there greeting? So on and so forth. Okay.
okay, so
Anybody else who's able to run the whole thing?
Yes, sir, I'm able to run.
Okay. So then. Okay, this is fine. So let's continue. Swami.
yes,
Now we are clear till here, right? What is documents? What is classes? Right? 27 documents, 9 classes, 48 unique words which go into the input, right?
yes, sir.
Now, okay, now let's go. Now they are creating training and input data. Sorry, training and test data, right? Output empty, 0 into length classes. Why is it output is empty? Because it is just creating a placeholder for all the 9 tags, and it will then fill the 9 tags by encoding them, right?
Yes, sir.
Output row, okay. Output row classes index doc training append dot bag output row. You can just see how the training data looks like, huh? Just to be sure.
This all is okay.
Yeah. Okay. So it is converting. So except to everything, it will be one. One of them will be one, right? Or
Yeah.
not?
Yes, sir.
Yeah. So it is basically one hot encoded your dictionary of words and using it to represent your input.
Yes, sir.
Is this clear to everybody?
Should I go ahead?
Yeah. Please go ahead.
This is the
Yeah.
change.
This is the old. I mean, this is the old TensorFlow version. So you can actually, I would recommend use Kira's model as here as well. That's not for you only, everyone in future when you like do something else here, right? So okay, go down please.
This they picked up some DENN model from TF Learn and
Yeah.
they're fitting on this.
Yeah. That's fine. That can be replaced by your favorite any favorite Kira's model, Kira's setup.
Okay, sir. So 1000 epochs it executed and then I think saved the model. Then these are the helper methods. Bag of words. So this is the input. We're converting it to bag of words.
Mm-hmm. Okay. Okay, and So basically, the input is converted into a bag of words, and the classes are the 9 classes. So we have to predict which 9 classes are, which of these classes are there, right?
Yes, sir. I'm printing it as well. So these are the things. Is your
It is stemmed. Yeah.
these stamped? So these 4 words it was able to find in
Yeah.
the bag of
Yeah,
words.
but again, I see again. To be honest, stemming has a lot of utility, but when you are reading the stem words, it doesn't make sense at all. So in that way, some people avoid using stemming. Yeah. Whenever you start using stems, you start thinking, why does it look so odd? So see, it has converted shop to op. No, sorry, it has converted open to op, I think. Yeah.
Yeah, and yo to yo.
Yeah. Okay. That's stemmer. Okay. And they have different stemmers, I think. Okay. So goodbye greeting. So even goodbye greeting and hour, they are being encoded somewhere, right, Soumya?
Yes, sir.
The tags. Okay. Let's continue.
So we are P is coming from this. This is the phrase P. We convert it to bag of words. Then we are predicting using the model on the
Ah,
P.
okay.
So we got these and
So the highest one will be the answer.
okay, sir. Um,
In this one, I think the third one looks. No, not third one. There are a couple of others. Yeah. Yeah. Argmax. Yeah. Zero. Zero is not the biggest one.
sir, these are very small. To the minus 14 and
Okay.
but it was not there. There is some issue.
Yeah, there's some issue. So looks like the. Okay, I think argmax has been used in the code. Can you just check that?
Yes, sir. So after this, is it saving the model using pickle?
Yeah, that is big. Yeah, it is saving everything, including words, classes, list, everything.
Yes, sir. It is again doing same prediction using after loading the model and so it is giving us here open today is 0.79
Yeah,
which is like this one I think.
correct. Yeah, but it is predicting not the threshold, but the tags here in this case.
Sorry, sir.
Sorry. It is not predicting the tags, but the context here, right? Because error today, open today was a context, not a. No, yeah, it was not a tag, right?
Yes, sir. It was not a tag. Yes.
Okay.
So
Okay, let's run and see what it is predicting. Classify. Oh, it will not show the context. It will show the response to you.
yes,
Classify is your shop open today. Okay, can you type something else there? Maybe how do you do? Hi, how are you or something? Meanwhile, rest of the folks, apart from the 3 people on the camera, how are you all doing? Is this happening for you? I think Santosh, for you it ran. You said right. Okay.
giving good results. It is classifying
Yeah,
it.
it is classifying. Okay, greeting. Is your shop open today? Okay, so this was like a very simple, not simple, I would say, maybe basic, but the whole idea behind this is this is how your a context aware chatbot can be created, where you are finding the intents using a trained model, right? Can you just change it, Soumya? Hi, how are you doing? To maybe something which is not in the list. So hope you are doing. No, maybe something really interesting. How is it going? Maybe how is it going? Yeah, let's see what it says. Yeah. It is still greeting, but it is now with some 0.61 score. But yeah, you see the benefit. So that is why in Rasa and other places, even if you give 4 or 5 examples, they are able to understand what the greeting looks like, right?
Yes, sir. Sir, one question here. So we
Uh-huh.
identified the intent. So
Hmm.
and we have the answers as well. So uh, as a next step, if I want to print the response as well.
So I think that is happening in the code, right? Is it not?
Yeah, it is happening. We saw that my shop is open from this and this time.
No,
Something.
but there is some chatbot thing there. Is not? It's not there. Like quit when you
Well,
it's over.
yeah, I mean, no, I didn't see that, but it is
Oh, okay, okay.
response. So both are things are there, classify and
Oh,
response.
okay. Response is there and classify is there as well. Yeah. Ah, because see, classify gives you the intent. Then you need to feed it to the next code, which will generate the response for you.
Okay, sir, got it. So if I
The
call
response calls again classify and get
within
the
somewhere
Yeah. Response will use the classify output to then
the
select the suitable response. Yeah. Anybody else wants to just share the screen? Thanks, Tommy. Anybody else wants to share the screen, please? Katrish, you can share your screen, please. Yeah. Meanwhile, go ahead.
sir, one more. So I mean, do we have some good data set which we can use, and any suggested uh, TensorFlow model instead of DNN?
Hey, DNN is an old one, right? So you can use any of the latest. I mean, this. See, at the end of the day, it is a classification problem. You have a text input and you have a label, which is intent, right? So just take the latest TensorFlow that Keras model, and so I just Google for TF TensorFlow Keras text classification, right? So that same model you can use instead of DNN. Okay. Is
Okay.
your shop open today? What kind of mopeds do you want? We have Piaggio, Vespa, and Yamaha. We want to rent a moped. Are you looking to rent today or later this week? This is very nice. Yeah. Can you like play around with the way the sentences are written just to see how it handles variation? Uh, we were thinking of renting a moped, or maybe we were thinking of getting a moped, maybe something like that. Very different. Thinking of getting a moped. Let's see how it does. Yeah, so the score is not high enough. 0.25 is the threshold you set in the code, right? That's the threshold you have set. So maybe instead of getting, if you put renting. Even there, it's not giving, okay? Maybe the error threshold of something like a point 3 or point 1 or something, 0.1. Yeah, so it is now giving you something, but not very exactly. But it's all the play of this confidence thing, right? So again,
Yeah.
not an issue. You can, when you see that something is performing slightly badly, all you have to do is maybe add a few variations in the
Okay.
data and just train it again.
Sure.
Okay, hope everyone is clear. Just Purnima, it is clear for you. You're able to run.
Yes, sir. I'm able to run. I can share it.
Yeah, no, that's fine. That's fine. I'm just checking. That's fine. I don't think this is really, I mean, that one, but the concept is very important. Pravina, you're able to run? Pravina is not there. Okay. Ritvik, you're able to run? Santosh, I know you have run. Ritvik, you have run? Ritvik is not there. Shipri, I think you have run, right?
Yes, but
Okay.
it signed out and stuff. So I'm just loading it again.
Okay. Swami has done. Varaprasad, have you done?
Yes, sir. I am running, sir.
Okay, but it's no errors, right? Till now.
At first module only error came. After then I put this TF learn. Then it is gone, sir. Just slowly running.
Okay, cool. Let us know in case of any issues.
Yes, sir.
Vinay, you have run this? Okay, Vinay is not there as well. Okay. Kathirishan is run. Ashutosh is not there. He is not there for the day. Srihari, are you there?
Here is not.
Okay. So okay, hey Hasita, how many people have submitted the quiz? Almost all of them.
Oh, yes, sir. 12 students.
Okay, what's the average score?
From 65 to 70.
Okay, what's the highest score?
I think 95.
95. Okay. Can you just message me on the chat, not here, but my chat, the score thing, if that is possible?
Yeah, sure.
Thank you. Okay, so I think just give me a second. I'm just trying to find a better or slightly more complex. Now that we have done this, there is a Kaggle intent thing as well. Yeah, so the Keras TensorFlow. Okay, thank you, Asita. Yeah, I think everyone has submitted the quiz. Any major doubts on the quiz? We just wanted to. I just saw the marks. So it's on an average, I think around 65 to 70% people have scored. What were the any major issues there in the quiz? Any challenges?
Bit confusing, sir. Some answers,
Bit confusing.
options.
Okay, so what
Confusing.
was so confusing in the sense you were not able to make out if there's one answer or all of the
Yeah.
above?
Yeah, yeah.
Okay, okay. Okay, so yeah, because see, some what typically just to avoid like random guessing, what we typically do is maybe add deliberately maybe answers which are there, multiple answers for the same question, just to check the understanding, and also adding some things which are very similar, right? But yeah, I'm happy to see that some of you have actually uh, got close to. I think one of you has got 19 as well, quite good, and a lot of people in 15 16 as well, so that's quite good. And I think some of you were absent in the class, so it's understandable, some of, because as I did create the quiz specifically going by the topics covered in class, so that's not an issue, but make sure you cover the missing items on video or whatever the materials being uploaded on the LMS. So yeah, I was just wanted to share this code with everyone. TensorFlow and Keras in Python, the text classification, it is written in May of 2022, so it has to be the latest, right? So just in case, definitely, in fact, not just in case, we want to replace this TF code, DNN code with the latest text classification. So Swami, to your question, just replace the text classification where it is predicting intent with this code given here. Okay, so it is using TensorFlow 2 and Keras in Python, both the latest ones versions. Okay. So that
So then we can use this particular model.
yes, you can.
Thank you, sir.
Yeah. So again, Swami, just I mean, I know you know this, but it's just to replace the or make your code state of the art in terms of the not state of the art but latest model in to replace that DNN model, which is like 2 years old, 2.5 years old, right? Okay. So yeah, before we move
One
on to the
doubt.
next, yeah, go ahead.
Sorry. So in the chat board, so we had some intents and patterns and responses.
Hmm.
How do you capture if it does not fall into any of the pattern? Is there a catch-all that you usually have to give? Because when I say, is your shop open today? It says yes, 9 p.m., 9 a.m. to 9 p.m. But when I say, where are you? It says we accept credit cards.
Yeah.
If I say,
So
where are you open today? If I ask the question, where are you open today? It says our hours are between 9 a.m. and 9 p.m. So I was,
okay, yeah, good one. So you are testing the chatbot, right? And you're finding it is not covering every scenario. So two ways to handle it based on the discussion in the morning. One is you should have this threshold and that strict threshold, right? Probably very high, right? So whenever it is not meeting those thresholds, when you say where are you open today, it will not meet probably a zero point 0.6 similarity score, right? Zero point 0.6 or 0.7, I'm just saying, right?
yeah,
So then you should say, I'm sorry, can you repeat your question? I'm not understanding. Something like that, right?
got it.
And also the best is to like see this intent.json was a toy example, very basic, very basic. When you are creating a production related thing, you will probably look at the old interactions of the customer and run NLP on that and come up with all these intents. So it can be cancel, booking, modify, whatnot, right? 10 things or whatever. So you'll have to do this very interesting. I would not say it's boring. Very interesting analysis on the past interactions, and it might be on phone, it is on phone. Then you will have to do a interview of the people who take the phone, right? Or who man the calls. You'll say, okay, what calls do you receive in a day, right? So that will help you in creating that intent.json file. So this intent.json file will be very good, very comprehensive, and Even after that, if they are asking something else, then you can say things like, okay, please repeat, or you can say drop a message saying I am only covering these 5 issues, something like that, something like that. So that's how you
Right.
handle. Yeah.
Because for the classification itself, if you see, is your shop open today?
Hmm.
The open today is something where they have tagged it as 0.43, and in the classification of where are you, it is tagging the payments as 0.41, which is like a very close threshold, but payment is nowhere related to where are you, right?
Correct, correct. So
How
it
do you then
also,
determine a threshold if it is actually passing the threshold?
that's good one. So again, good question. So again, thresholds are a function of the quality of model you have built, right? Bag of words you are using underlying, right? Bag of words, even though it is working in a lot of cases, but for the perfect, now we are, bag of words is like very obsolete nowadays, right? Bag of words, instead of that, you can probably use maybe something transformed by a custom model, right? Maybe you trained something on a huge data set, maybe a doc2vec, which is again not latest, but doc2vec maybe trained on a huge data set, maybe a BERT model or something which converts words to vectors, and then do your this comparison, right? So instead of that bag of words thing to convert words into vectors, use something really powerful. Then the vector quality will be very good, and then your vector comparison you will get accurate comparisons, and thresholds based on that will give you good results. This was the reason for this threshold not being that great, or rather not being that clear when you are not clearly separating out, is because it is just a basic bag of words model where you are converting, right? So it has its own limitations. Bag of words obviously can't take into consideration the semantics of the word, right? So the word bank of the river and bank of or State Bank of India, the bank, that bank are the same in a bag of words, right?
Right, right.
Okay, so that's the issue.
Got it.
So, that's okay. So I've shared that Discord. Let's. I'll just introduce the next topic before we take a lunch break. For that, I'll just share my screen as well. Uh, so Deep Pavlov is the next topic. Have you heard of it? I did talk about it in one of the earlier classes, probably, but not in detail. But have you has anybody if you heard about Pavlov? Deep Pavlov? Okay. Let's learn about Deep Pavlov. Very interesting thing or module. So it is an open source conversational AI framework. Okay, and very good documentation as well. So let me just open. In fact, let's go to the GitHub, and there is a demo link here. So I'm pasting the demo link. You all can open it on your side as well. So, so Deep Pavlov is an open source, makes it easy for beginners and expert to create dialogue system. See the sections below to get started. So lot of documentation. Okay, see tutorials. In fact, it's like Python code is there as well. See the guide for experts as well. It can integrate with SQL and all, right? So we will see when we come back. I'll show you the key aspects of Deep Pavlov. They are very good, right? And uh, just to make you aware that there is something like a Deep Pavlov, which you can using this again, yet another module or a framework, which can help you in creating a chatbot, right? That's the whole idea. So just so the before we take a break, that I mean, once we come back from the break in an hour, the agenda would be to go through Deep Pavlov, run some simple codes. Okay, that's the agenda. So any questions in for a few minutes before we take a break?
Now, which one is the best one we can use, sir? Like we have learned many frameworks.
Yeah.
You
No.
suggest
So
based on your
yes.
experience.
Okay. Yeah, based on my experience, I would say what we make in Python, right? See, Rasa is very good. Rasa gives you good output as well, right? So, and Rasa can be customized. So definitely try Rasa like frameworks. Google Dialogflow also is very good, right? But when you need a lot of customization, probably the intent based thing which we just created, you are just looking at, right, is also an option. Based on your business requirement. If there is too much customization, you can use your Python code as well. But as I said, Rasa is nowadays a lot of people. I have seen even in my teams, people are using Rasa. So try Rasa, but have a look at Deep Pavlov as well. So now the idea of giving you all this knowledge of all this is introduction rather to all of this is that you can make an informed choice when you are given all these options, right? In future, if you have a problem to solve, you can try, okay, is Deep Pavlov the most feasible? Or maybe I can write my own Python code. Or if Rasa can do the trick, I can just go for Rasa, right? That's the whole idea.
Sure, sir. Thank you.
Problem. Any other questions?
I have a question, but
Mhm.
not related to the whatever the context we are speaking. But as officially, this is the fourth week of the module. So fifth week will be a final assessment, right?
We have to check. Hasita, can you find that out, please, for us?
Because
Yeah, I'll
next
check
week,
and
Ashita just wanted to inform next week we are having Varma Lakshmi festival on Friday. So
Yeah. So
okay, I will check and come back.
yeah. Check with Dr. Shinu and team, please. Hasita, and let us know.
Yeah, sure.
yeah,
Yeah.
we have internally spoken with. I have internally spoken with the team. Like many of them are in having that festival, so that's the reason.
No. Even even I'm happy to get a chutti, so that's fine. Okay. So yeah, no issues there. There is a holiday. We'll definitely have a holiday. So no worries. That's so
Okay.
let Dr. Shinu come back on that. Yeah.
Okay.
Any other questions? Even
And
holiday
also,
questions are
sir,
fine. Yeah.
in the exam patterns,
Hmm.
so I saw quiz 1 and quiz 2 also there as a part of the lesson plan.
Okay. So I mean, do you mind if I maybe convert it into a project, right? So
Yeah.
So that's
Sure.
something which I have to discuss and decide. Let's get back. So probably in second half, maybe we can discuss with Dr. Shinu. I'll invite her and we'll discuss on the quiz. The project thing. So yeah, it is written in the thing, but maybe midway I changed my mind. So I was just
Okay.
looking at probably a project because that would give you a better learning,
Sure.
right? Yeah,
Yeah.
we can still definitely have maybe a small exam, right? But I would probably, I see again, learning is the most important thing here, right? So
Correct, sir.
that's I would say a project. And now that you know a number of frameworks from the 4 days we have covered, 3.5 days, half day still left, you can probably do a project, decent project, I'm sure.
Yes, to
Great,
add
sir.
on to this previous
Yeah.
one module or something, we had the same pattern, project pattern, group project pattern, like three
Okay.
or two groups they would do and
So how much time were you given for that? May I know that? How much time did you have?
So they were given 1 week.
1 week for okay. Okay. So okay, fine. Okay, so let's discuss in the second half. Yeah.
Sure, sir.
Okay. Let's take a break. Meet in 1 hour approximately. Okay. Bye.
Okay, sir. Thank you.
thank you.